Access, the industry's first type-approved positive train control solution. The deadline for meeting PTC implementation is approaching fast. New regulations for improved rail safety must be met. Choosing an experienced partner and proven solution is the best way to ensure a successful implementation. In the early 2000s, Alstom successfully addressed the PTC issue with Access, Advanced Civil Speed Enforcement System. Access has operated successfully on the Northeast Corridor for more than 10 years, where it provides PTC support for high-speed rail, commuter services, and freight traffic. Access fulfills the congressional PTC mandate requirements and is available to the market today. Access also addresses key rail industry needs, providing proven reliability, the most operational experience of any proven PTC solution. Reduced risk. Access functionality is already proven. Prioritized operations. Optimal system availability and throughput are well established. Ease of commissioning. Extensive laboratory system tests reduce the risk of field rework. Alstom's Access is the first FRA type-approved PTC solution in North America. It is utilized on hundreds of vehicles and track miles. So how does Access work? The Access solution is comprised of 4 subsystems: onboard systems, wayside systems, communication network, and a central office. Together, these subsystems form an integrated solution that meets mandated safety requirements. Access benefits from highly reliable and accurate train positioning technology made possible by the use of transponders. Strategically positioned along the track, transponders send precise location data, track information, and civil speed limits to the train as it passes over them. Civil speed enforcement data received from the transponder is processed by the train's onboard computer and presented to the train operator. If the train is exceeding a safe speed, a warning is issued. If the warning is not addressed by the train operator, the computer sends a request for the brakes to be applied. When approaching a home signal, the onboard computer enforces a positive train stop when the signal is red. The signal and interlocking are continuously monitored by the WIU, which transmits the signal and route status to the train by radio. When the route is lined and locked and the signal is set to green, the positive train stop is overridden and the train is allowed to proceed. Additionally, the train receives temporary speed restrictions from a highly specialized Access safety server. Using the information provided by this server, the onboard computer can notify the train operator they will soon have to decrease the train's speed or be able to accelerate. If an operator does not react properly, Access will automatically enforce restrictions. Enforcement of these speed restrictions provides a safer environment for railroad workers performing track maintenance and will slow or stop a train approaching a defective grade crossing. Highly stable and accurate positioning capability makes Access the industry leader for rail lines with multiple parallel tracks. Access wayside equipment supports high-speed, commuter, and freight traffic, allowing these different types of equipment to operate safely on the same track. Access also supports high-density environments. The centralized data and maintenance server collects information from all Access system components, including signaling and communications devices. Processing of this data quickly identifies components not working properly, as well as their location, thus minimizing system downtime. With Access, your passengers and freight all arrive safely. Alstom rigorously tests every customer's PTC application, as well as each individual component prior to field installation. Systems do not enter revenue service until they've passed all aspects of FIVP testing. Testing is performed in Alstom's Factory Integration and Validation Platform, or FIVP Lab. While each customer's needs are unique, typical FIVP lab testing goes as follows. During product testing, each device of an Access system is individually tested with real data and an environmental simulator. During system integration, combinations of access devices are integrated into operating subsystems that are also tested with environmental simulators. During system testing, the entire new access system is completely tested, first and most thoroughly using real customer-specific data and simulations in the FIVP lab. Next, system testing occurs again in the field. The FIVP lab is unique and highly effective at preparing the customer's PTC application for revenue service. Alstom takes every precaution to eliminate issues and achieve maximum system readiness prior to field installation and commissioning. Installed and operational on the Northeast Corridor for over 10 years, access will expand to cover the entire NEC and beyond. For service and support, the Northeast Corridor is supported by Alstom's Newcastle, Delaware facility, providing equipment, repair, replacement, diagnostics capabilities, and the ability to warehouse and manage customer spare equipment. Further west, Alstom has world-class service facilities in Naperville, Illinois, and Mare Island, California. Access has been providing safety in revenue service on the Northeast Corridor for more than 10 years. Alstom is a world leader in rail transportation systems and technology. With Access, Alstom delivers the best solution to meet your PTC requirements. Access is also unparalleled in flexibility, which stems from its modular systems and capacity for incremental deployment. Regardless of train type and speed, single line or multiple parallel tracks, Alstom's Access solution can be installed with minimal operational interruptions. Access is the U.S. rail industry's first type-approved positive train control solution.